All right, we're rolling, so let's see. Now we're going to do some examples that are going to jumble in all three of our learning targets. So we're going to be doing order of operations, we're going to be evaluating expressions, and we're going to be simplifying either to get a number or to get a simplified algebraic expression. And it's not like one of these, one of those, it's all mixed in together. Okay? Now, one of the properties we talked about yesterday was the distributive property. And this slide that I copied here has the distributive property work in this way. It says if you have A times the quantity B plus C, here's all the letters. It's A times B plus A times C. It's the number outside the parentheses times each number inside the parentheses. And since it's a plus sign there, it's a plus sign between the two multiplications. And then look at the other one with a minus sign between them. A times B minus C is AB minus AC. You multiply the number outside the parentheses times each number inside. But since it's a minus sign inside the parentheses, it's a minus sign right there. Let's look at a couple of examples. So we're supposed to rewrite each expression using the distributive property. Then simplify. Well, if it can be simplified, it can't always be. So let's see here. So for part A, we have 7 times the quantity, 3W minus 5. The distributive property says to multiply the 7 times the 3W, put down a minus sign, because put down whatever that sign is, right? If it's a plus, put down a plus. If it's a minus, put down a minus. And then multiply 7 times 5. Now do the multiplication. We always do multiplication before we do subtraction, right? Do the multiplication. 7 times 3W. Well, 7 times 3 is 21, so that's 21W. Copy down the minus sign. 7 times 5 is 35. And remember, like terms, we're going to talk about those again in a minute, but those are unlike terms, so we can't do anything else to that. We're done. Now, we talked also yesterday about how sometimes you can do a step in your head and not write it down, and that's not skipping a step, it's just mental math. Could I have done that step right there in my head? If you can't yet, you need to work towards being able to do that step in your head. You're just going to get tired of writing it down. And if you're like me, after a while, you're just as likely to make a mistake writing something down as you are doing it in your head. So get to the point where you can mentally go, 7 times 3W is 21W, 7 times 5 is 35, and make sure you get the right sign between them. You need to be able to do that. Okay? All right, part B, a little more complicated. 4 times the quantity, 6V squared plus V minus 3. Well, let's multiply 6 times V squared plus 4 times V plus, actually, I could write it this way, couldn't I? If I actually follow what this thing says, minus 4 times 3. That's the distributive property. I used it on 3 terms inside the parentheses this time instead of just 2. I don't care how many terms are inside the parentheses. You can still use the distributive property. All right, now, what is 4 times 6V squared? 24V squared. 4 times V, 4V, negative 12. Are any of these terms like terms? No. We're done. Any questions? Okay. We're not doing I. Maybe later. I'm not sure, but for now, no. Okay. Now like terms. And as you evidently remember, because y'all didn't fall for any of the unlike terms, like terms have to have the exact same variables with the exact same exponents. So an x squared term and an x term are unlike. an x squared term and a y squared term are unlike. It's got to be the same letter with the same exponent on it, okay? So 5x squared, so the 5x squared, the 2x, and the negative 4 cannot be added together. Neither can the 6a squared. Oh, the 6a squared and the a squared can be, and get what? 7a squared. Just add the coefficients. Don't change the exponent when you're adding. That's when you're multiplying that you change the exponent. Just add the coefficients. So that would be 7a squared plus 2a. All right, so let's keep going here. Simplifying by combining like terms. 17u plus 25u. Are those like terms? Yes. All we need to do then is add their coefficients. What is 17 plus 25? So we get 42u. Not u squared either. Just all you do is add the coefficients. Do not change the exponent on the variable at all. Not when you add or subtract. Okay? On part B here, 6t squared plus 3t minus t. Are there any like terms? Those two are like terms, aren't they? Okay? So copy down, and what was my note? Oh, that negative t is the same thing as negative 1t. Right? We knew that, right? So copy down the 6t squared, because there's nothing to add to that. And then what's 3t minus t? 2t. So this is really quite a bit easier than what you were doing on that numerical skills worksheet. Few more. Let's start combining things. Now we're going to use the distributive property, then we're going to combine like terms. Now, first, I do need to look and see. Order of operations says simplify inside grouping symbols. But look, you can't, and you can't there either, can you? They're unlike terms. So there isn't any simplifying to do inside the parentheses. That means use the distributive property. So I want to multiply 3 times 2q plus 3 times r. And again, we need to get to the point where we don't have to write this down like I've written it down. Then I put a plus sign because that's what's in the problem. Then I multiply, distribute again, 5 times 4q minus 5 times 7r. Now I need to actually do the multiplication. And again, if you're able to not write that line down and go to the one I'm getting ready to uncover, great. You need to get there if you're not there. So 3 times 2q, 6q. Just multiplied the coefficients. 3 times r, 3r. 5 times 4q, 20q. Negative 5 times 7r, negative 35r. Don't mess up your signs, right? Keep the positive ones positive, the negative ones negative. Now, there are some like terms. That's a q term, that's a q term. I can add them together. That's an r term, that's an r term. I can add them together. So 6q plus 20q is 26q. 3r minus 35r is negative 32r. So you write down as much as you need to write down, but try to get to where you can do the distributive property in one step instead of two. I'm doing it in 2 steps for now. I won't keep doing it in 2 steps because you're able to do that. It's been a while, so maybe you're not right now, but you're able to do that. All right, work out number 5 and see what you get. See if you can simplify inside the parentheses, and then when you find that you can't, use the distributive property and then combine like terms. Be careful with that negative sign on that second parentheses. That's a -2 that you distribute. And then check and see if I got it right. Did you guys get what I got? That's only when you're multiplying or dividing. Yep. All right. Any questions? Okay. Almost done. Absolute value. One thing you need to know is an absolute value sign is also a grouping symbol. So you work inside the absolute value sign just like a parentheses, if you can first. And then you know the absolute value of a number is its distance away from 0, right, on a number line. So -4 is 4 spaces away from 0, so the absolute value of -4 is 4. Well, 4 is also 4 spaces away from 0, so the absolute value of 4 is also 4. What two numbers have an absolute value of 6? 6 and -6. Okay? You with me? Nah. We won't have to yet. All right, so let's take a look at these two examples with absolute value signs. We're supposed to evaluate an expression. This time, we have a variable expression with an n as your variable, but they tell us what n equals. So, the first thing we need to do is copy our expression down, but replace n with what? -7.5. So, that equals 8.4 minus absolute value of, and try to make your absolute value signs big enough so that they don't look like ones, because a lot of times mine end up looking like ones and then I'm confused. Technically, no. I slant them sometimes to make it a little more noticeable it's not a 1. Now, 2n, so that'd be 2 times -7.5 plus 5. Now, remember, the absolute value sign is a grouping symbol, just like a parentheses is. So leave the 8.4 alone, leave that minus sign in front of there alone, and work inside your absolute value sign. So inside the absolute value sign, should I multiply first or should I add first? Multiply. What is 2 times -7.5? -15. So -15 plus 5 is what I have inside there now. Now, still don't take an absolute value of anything yet. I need to get a single number inside of there. -10. -5 plus 5 is -10. So leave the 8.4 there, leave that negative sign, and inside your absolute value signs you have -10. Now it's time to get rid of your absolute value sign. So look, here's what I'm going to do. Copy down 8.4. I copy down that negative. It's this negative right here. It's that one. And then, what's the absolute value of -10? 10. So look, there's still one minus sign, but it's not the one that was inside the absolute value signs. It's the one that was in front of the absolute value sign. Correct. Yeah. Once you simplify an absolute value, you'll never get a negative from that. So make sure you realize the reason that negative sign's there is because it was in the original problem. Okay? And then 8.4 minus 10, I left off a negative sign, didn't I? Is -1.6. All right, we still good? All right, let's make it as complicated as I know how. Let's put a fraction in there. So 1 1/3 minus the absolute value of 2y plus 1 if y equals negative 2/3. So 1 1/3 minus the absolute value of 2y, y is negative 2/3, so 2 times negative 2/3 plus 1. Now, a lot of the time with fractions, I end up having to change to an improper fraction to do the rest of the simplifying. I don't know if I'm going to need to or not, so I'm not going to yet. Because we know, well, either we know or we can figure out that 1 1/3 is the same thing as 4/3. Maybe I need to change it to 4/3, but I don't know. So I'm going to leave it as 1 1/3 and see if that works out okay. So 1 1/3 minus. Now, inside your absolute value, do the multiplying. What's 2 times negative 2/3? What's 2 times 2/3? What's 2 times 2? 4. So 4 over 3, and positive times negative is negative, so negative 4/3. If you follow me on all that? Multiply the whole number times the numerator. 2 times 2 is 4, and you know that a positive times a negative is negative, so negative 4/3. Plus 1, or plus 1. Ooh, and look what I did, though. Why on earth did I write the 1 as 3/3? Because it equals 1, and I need a common denominator, don't I? To add or subtract fractions, I need a common denominator. So keep that as 1 1/3 minus, now inside, so look, I still have the absolute value sign there. I've got a common denominator. Add the numerators. Negative 4 plus 3 is negative 1. So negative 4/3 plus 3/3 is negative 1/3. Did you follow me? Maybe. I mean, would you know that negative 4/3 plus 1 is negative 1/3? Then make sure you change it to 3/3 then. All right, like we did before. When I copy the problem down, there's already a negative sign in the problem. That's that negative sign. But the absolute value of negative 1/3 is simply 1/3, isn't it? And so as it turns out, I'm glad I left that as 1 1/3, because 1 1/3 minus 1/3, doesn't that leave you with 1? Because 1/3 minus 1/3 is 0, right? So that'd be a 1 plus a fraction of 0. Questions? All right, we have some worksheets. Let me look at that here in a second. Yeah.